Okay, question 4C. Excuse me. How are we going from -5 to -40 to -320? What is happening for that? So we are multiplying by by 8. Make sure that 8 works for everything, which it does. So what that tells me is it's a geometric sequence that has a common ratio of 8. So then we want to go through and find, using our recursive formula that we've been using, that the previous term where we left off times the common ratio, in this case, will be 8. So this is the formula we would use for this specific sequence. So we left off on negative 2,560 times 8. Go to your calculator. And we get a large number of negative 20,480. And then multiply that by negative 8. Or sorry, by 8. And the other number, the second term we get is negative 163,840. So negative 163,840. Letter D we did not do. On letter D here, we need to figure out what's going on. 1/3 to 2/3 to 1 to 4/3. Don't forget to think about 1 as the same thing as 3/3. So what we are doing here is adding fractions. We're adding a third. 1/3 plus 1/3 is 2/3. 2/3 plus a third is 3/3. 3 divided by 3 is 1. 3/3 plus 1/3 is 4. So because we are adding, it's an arithmetic sequence. Therefore, we have a common difference, which in this case is adding a third. So we're talking arithmetic. So the recursive formula for an arithmetic is this right here. And for this specific sequence, we are continuing to take the previous term plus a third. So we left off at 4/3. Plus a third is to add the numerators, keep the denominator. Then 5/3 plus the third is 6, which we reduce down to 2. So the next two numbers are 5/3 and 2. Fractions. All right, next ones. We did all that in class. Letter D, number 7, letter D. Find the 7th term in this arithmetic sequence. Now, it's arithmetic, so we're adding or subtracting something. We're starting at 4, going down to -8, going down to -20, going down to -32. So we're adding to go from one to the next, which in this case, we're adding a negative. A negative what? Negative 12, okay? So 4 minus 12, there you go. So it does confirm it's an arithmetic sequence. So the formula for an arithmetic sequence, the explicit formula, is taking the initial value plus the common difference times n minus 1. So you got to know what the initial value is. You got to know what the common difference is. Where does the sequence start off at? It starts off with a 4. And what is happening to it? We're adding a negative 12. So the explicit formula then is starting at 4, we are subtracting 12 each time, and then n minus 1. So if I want to now find the 7th term, I'm going to go to my calculator and do 4 minus 12 times 6. The 7th term then is got a value of negative 68. Okay, number 8 here. Find the missing term in the sequence. So let's figure out what in the world is going on here. From 7 to something to 63 to 189. 63 to 189, that's where it's at. We jumped up quite a bit. Are we adding it or are we multiplying it? It doesn't look like we'd be adding anything. 63 times 2, let's take a look there. That's 126. 63 times 3, there's a 189. So it appears we are multiplying by 3. So if I do that, 7 times 3 should be 21. 21 times 3 is 63. That continues to make the pattern right. 63 times 3 is 189. 189 times 3 is 567. And if need be, this would be considered a geometric sequence. Letter D. Numerators are staying the same. They're staying threes, but the denominator is going from 2 to something to 8 to 16. So it's going to be, looks like 3 over something, because that was not changing. But what's happening to that? The 2 to 8 to 16 looks like it's being multiplied by 2 in the denominator. So technically what we're doing is multiplying by a half. 3 times a half, 3 times 1 is 3, 2 times 2 is 4. 3/4 times a half, 3 times 1 is 3, 4 times 2 is 8. 3/8 times a half is 3/16, and 3/16 times a half is 3/32. Okay. Number 10. Suppose you're rehearsing for a concert. You plan to rehearse the piece you'll perform 2 times the first day, then to double the number of times you rehearse the piece each day into the concert. So, double. So 4, and then 8. Oops, if I could add. And then 16, and then 32, and then 64, and then 128. And I can continue on this problem. So you plan to rehearse 2 times the first day, which is here. And then after the 6th day, where are we at? We are at 64 practices. And number 11, a certain culture of yeast quadruples every 3 hours. A scientist places 9 grams of yeast in a culture dish. What is the weight of the yeast after 15 hours? Okay, this is a bit of a tough one because there's quite a few things going on here. First off, we're quadrupling. So if we start off with 9, okay, in our sequence, we're starting off with 9, and then we quadruple it. 9 times 4 quadruple means 36. And we're doing this every 3 hours. So as we do that, what we need to figure out here is we want to know in 15 hours what's going on. So what that means is it's quadrupling 5 times because it does it every 3 hours. And in 15 hours, that means there's 5 quadruples. So I can continue on this process of doing 5 of those. 36 times 4 is 144. It quadruples again for the 3rd time. We're at 576, and it quadruples again to get me times 4, 2,304, and then it quadruples one more time. It's going to have 5 quadruples. We start off with 9, and then we do 5 quadruples. Because it quadruples every 3, and in 15 hours we have 5 of those. So 2,304 I wrote times 4. So it's on the 6th term, we're at 9,216. Now that's just kind of brute forcing it doing a table. Another way you can look at this is because it's multiplying, it's geometric. So the explicit formula for that is this right here. We're starting off at 9. We are quadrupling. So what I want to do then here is, excuse me, do 1 second before I tell you wrong. Okay. We are technically talking about then on the 6th term that after 5 quadruples, that's what we're running into. So 6 minus 1, that's where I'm getting that 5 quadruples. And when you go and type that into your calculator, you're going to find that you have 9 times 4 to the 5th, which turns out to be 9,216 grams. Okay. Letter C, it's an increasing line, so that means it's arithmetic. And just a few other things. Again, it's increasing. It's a linear function that happens to be discrete. And that's about it.